Welcome back. I am absolutely thrilled you're here for this explainer today because, well, we are going on a highly focused, almost forensic mission. We're going to reverse engineer a true commercial titan, the classic 8 vegetable juice. You absolutely know the one I'm talking about, right? It's that ubiquitous, kind of nostalgic drink you see sitting on airplane beverage carts and lining supermarket aisles literally everywhere. But listen, we aren't just whipping up some casual kitchen recipe today. Oh no. We are breaking down the exact scientific protocols, the cellular biology, and the thermal mechanics required to perfectly replicate that iconic, savory beverage right from the ground up. So grab your lab coats and let's get right into it. Okay, let's kick things off with a question that has probably deeply, deeply frustrated anyone out there who has ever owned a home juicer. Why is it that throwing a bunch of fresh, raw vegetables into a cold-pressed juicer never, and I mean absolutely never, produces that familiar, savory, thick, store-bought taste? I mean, you buy the exact ingredients listed right there on the back of the bottle, you run them through your super expensive machine, and it always comes out tasting completely wrong, right?
Here's the thing. When we think of juicing, we almost universally think raw. It just makes sense. But if you attempt to run raw tomatoes, celery, and carrots through a standard juicer, that expectation just falls completely flat. You end up with this watery, pale, and highly acidic liquid that honestly tastes more like a watered-down salad than a satisfying drink. But the commercial reality? It's an entirely different beast. The commercial formula we're analyzing today was actually engineered way back in 1933. And get this, it is entirely based on a pasteurized, cooked product. That is exactly what yields that robust, deep, savory flavor we all instantly recognize.
So here's our mission briefing for today. We'll start with Section 1, the raw juice fallacy. Then 2, engineering the vegetable payload. 3, the science of heat. 4, liquefaction and blanching. 5, filtration and calibration. And finally 6, the fiber loss paradox.
All right, jumping right into Section 1, the raw juice fallacy.
The absolute most crucial point you need to understand is this. You must cook the primary vegetables first. Seriously. To achieve the exact fluid viscosity and that deep flavor profile of the commercial product, we literally have to completely abandon the whole idea of raw juice. See, raw vegetables hold their cellular structure rigidly, and they release these sharp, really unrefined acids when they're simply crushed. Without applying thermal processing to physically break those cell walls down, your yield is always going to be that disappointing, pale, acidic liquid we just talked about. So heat isn't just an option here. It's the mandatory first step to unlocking the whole matrix.
Moving on to Section 2, engineering the vegetable payload.
Now, what is truly fascinating here is the sheer imbalance of the ingredients. When you hear the phrase 8 vegetables, you naturally picture this even, perfectly balanced medley, right? But the matrix is actually heavily dominated by a massive 90% tomato base. It's practically all tomato. The remaining 10% is where the roots and greens come in, essentially acting as this highly specialized backup team. That tiny little fraction is specifically calculated to provide those essential earthy, aromatic, and peppery chemical compounds that transform just a plain old tomato juice into a complex, savory beverage.
Let's look at the specific hard vegetables to really understand the level of precision required here. Our 90% core requires exactly 3 pounds of Roma tomatoes. Roma is the absolute optimal choice for this because it has a very high flesh-to-water ratio, which keeps our base from becoming way too thin. Then, for our roots and stems, we need 2 chopped medium carrots, 2 chopped celery stalks, and exactly 1 small, peeled, and diced red beet. And guys, whatever you do, do not skip the beet. That single red beet is the absolute linchpin of the whole operation. It provides the necessary deep crimson pigment and those earthy sugars needed to stabilize the entire matrix. To round out that final 10%, we deploy our delicate greens. We need 1 cup of fresh spinach, 1 cup of chopped romaine lettuce, half a cup of watercress, and a 1/4 cup of fresh parsley. The spinach and romaine kind of offer a subtle, grassy baseline, but I want you to take special note of the watercress here. In this highly specific chemical compound, that particular leaf is what provides the crucial, sharp, peppery bite that you instantly recognize the second the commercial version hits your palate. It's a total game changer. All right, let's talk thermodynamics in Section 3, the science of heat. So here are the precise thermal application steps. First up, we place those chopped Roma tomatoes and the hard root vegetables into a large, non-reactive Dutch oven. Second, and listen, this is a really critical structural point, we add exactly 1/2 cup of water. No more, no less. This strictly prevents the bottom layer from scorching while the vegetables take their sweet time releasing their own juices. Third, we bring it all to a simmer, cover it up, and let it cook for 20 to 25 minutes. And I'm telling you, during this time, that sharp smell of raw roots softens dramatically, filling the room with this incredibly rich, savory aroma as the thermal degradation begins. So, why do we put our beautiful fresh vegetables through this? Well, this is where the science gets really fascinating. Simmering physically breaks down the rigid pectin and cellulose walls of the root vegetables. But more importantly, the heat fundamentally alters the actual chemical structure of the tomatoes. It takes the raw translycopene and converts it directly into cislycopene. Now, this chemical conversion vastly increases the human biological absorption of the nutrient. Pretty cool, right? But from a culinary perspective, this shift is what drastically deepens that signature red color and deeply sweetens the flavor. This chemical transformation is literally the core secret behind that famous commercial taste. That brings us to section 4, liquefaction and blanching. Now we have to physically transform this hot, cooked mixture. Step 1, remove the matrix from the heat and let it cool for at least 10 minutes. You absolutely must respect this resting period to prevent a thermal explosion blowout in your blender. Because let's face it, nobody wants boiling tomato lava exploding all across their kitchen walls. Step 2, carefully transfer the cooked vegetables and all of their expelled nutrient-dense juices right into a high-powered blender. Step 3 is adding the raw greens directly into the pitcher. And finally, step 4, blend on maximum velocity for exactly 2 minutes until you achieve a completely uniform thick puree. I really want to highlight the ingenious little technique happening during step 3. By adding those raw, delicate greens, the spinach, romaine, watercress, and parsley, directly into the freshly cooked hot mixture, the residual heat instantly blanches them. This is a brilliant engineering move because it immediately neutralizes their raw, bitter, enzymatic enzymes. But because the exposure is so incredibly rapid, it happens fast enough that it doesn't destroy their delicate, volatile flavor compounds. It perfectly preserves that fresh, peppery bite we want. Next up, section 5, filtration and calibration. Okay, so even after blending on maximum velocity, the machine still leaves millions of microscopic cellulose fibers fully intact. It basically creates a thick, hot vegetable smoothie. To achieve that specific, watery viscosity of the commercial standard, we must physically scrape and press this liquid through a fine mesh sieve or a nut milk bag. We are purposefully leaving all that dry, bulky vegetable pulp behind in order to yield a perfectly smooth, highly drinkable aqueous matrix. Once it's filtered, that strained liquid requires some exact chemical calibration to perfectly mimic that commercial savory profile. We whisk in 1 to 1.5 teaspoons of kosher salt. Now, the commercial version is famously a pretty high sodium payload, so you can kind of adjust this to your own targets. Next, we add 1 tablespoon of fresh lemon juice. This hit of citric acid perfectly cuts through and balances all that heavy umami. Then we drop in a 1/2 teaspoon of Worcestershire sauce. This is absolutely crucial because it introduces these trace glutamates that secretly trick the palate and massively amplify the savory tomato base. And lastly, just a pinch of black pepper or celery salt. After chilling it for 2 hours in a glass pitcher, the suspension will inevitably settle at the bottom, so you must shake it violently to re-homogenize before drinking it. Finally, let's look at section 6, the fiber loss paradox. We have to stop and analyze the ultimate, slightly shocking paradox of our success here. By utilizing our filtration protocol to mechanically strain the puree into that perfect juice viscosity, we have actually successfully removed almost 100% of the insoluble dietary fiber from our vegetables. So we are facing a massive biological trade-off. To achieve perfect textural mimicry, we strained the liquid, creating a rapid-absorbing simple carbohydrate that flawlessly replicates the store-bought mouthfeel. However, from a strictly biological standpoint, for your digestive health, drinking the thick, unstrained puree, the low-glycemic, gut-healthy whole food smoothie, is vastly superior for your body, even if it completely fails the textural mimicry test. Which brings us to our core bias check. As our source material very clearly notes, this formulation is heavily biased toward replicating the exact sensory and textural experience of the commercial product. We successfully engineered this thing for mouthfeel, for flavor, and for that sensory nostalgia. But in doing so, we entirely sidelined holistic health and dietary fiber.
And honestly, that brilliantly illustrates the reality of modern food engineering. It leaves us with one final provocative question. Is achieving commercial perfection actually worth the nutritional cost? We've successfully built the exact 8-vegetable matrix from scratch, but in doing so, we essentially filtered out the very structure that makes vegetables so inherently good for us in the first place. It really makes you rethink what exactly is inside your glass. Thank you so much for joining me on this explainer today. Keep asking questions, and I'll catch you next time.